Hello students, you are welcome to MSI Edutech e-learning. Today is a wonderful day and I'm very happy, so excited to be in your class for today. Today we'll be treating trigonometric ratio 1, and in this class we'll be considering number 1, basic trigonometric ratio on sine, cosine, tangent with respect to right angle triangle. And I believe that you are ready for me in this class. Now let's start with this right angle triangle, and I want you to pay attention, because if you really pay attention you are going to find this topic very simple for you. Now let's take for instance you have a right angle triangle, okay. Now this side is called A, this is B, and this is C. And remember, we have 3 sides, 1, 2, 3. Now I want you to pay attention to this. The longest side of right angle triangle is called hypotenuse and is small b. Let's call this small b, let's call this small a, and let's call this small c. I believe you understand that, right? Now, in triangle ABC, the sum of the 3 angles will be equals to 90 degrees, which we can also call complementary angle. I believe you understand that, right? Now, we want to first of all apply Pythagoras theorem. And what is Pythagoras theorem? Pythagoras theorem states that, I'm going to do that with you, Pythagoras theorem. Pythagoras theorem states that AC squared equals to AB squared plus BC squared. And what does that mean? It means the longest side of the right angle triangle must come first, and doing that we are going to have B squared equals to C squared plus what? A squared. So B will give us the square root of C squared plus A squared. So this is what we call Pythagoras theorem. I believe you understand that, right? Now, apart from this, in right angle triangle we have what we call SOHCAHTOA. I know you've heard that before, SOHCAHTOA. Now the SOHCAHTOA explain to us, let me write this, SOHCAHTOA. Now this is angle theta. Sine theta equals to opposite over hypotenuse. Now this will give us, what is opposite? This is opposite the angle that face this side. The side that face this angle, we call it opposite. I want you to take note of that, because sometimes you might see question that they will turn the right angle triangle, they will turn it upside down. If you are not careful, you get confused. So this is opposite, which is C all over B. Okay, the second one is cos theta. Cos theta is called CAR, adjacent over hypotenuse. So this will give us adjacent over hypotenuse. So what is adjacent? This is adjacent A all over C. Now the last one is tangent. We call it tan. Tan theta equals to opposite all over adjacent. Now what is opposite? C all over A. Now this is what we call Pythagoras theorem, and this is what we call SOHCAHTOA. Now you need to understand when this type of question is given to you and you need to understand the application, where to apply this and where to apply this. So I'm going to give you questions that are related to Pythagoras theorem, and I will also give you questions related to SOHCAHTOA. I believe that you're ready. I'll be right back. Let's take a look at this question. Looking at the shape on the board, the question is find sine theta. Find sine theta. We have hypotenuse to be 17 and opposite to be x and adjacent to be 15. Now, to solve this question, you need to understand that sine theta equals to opposite all over hypotenuse. Now, look at opposite. We don't know the value of opposite. That means we need to find the value of opposite. And doing that, we are going to apply Pythagoras theorem. If you apply Pythagoras theorem, call this B A, call this B, and call this C. So this will give you AC squared equals to AB squared plus BC squared. So this will give you 17 squared equals to x squared plus 15 squared. So this will give you 17 squared. When this one crosses to this side, it turns to minus 15 squared equals to x squared. So this will give us 17 times 17 minus 15 times 15 equals to x squared. So 17 times 17 will give us, so this will give us 289 minus 225 equals to x squared. So minus this, we are going to have 64 equals to x squared. So x will give us square root of 64 and x will give us 8 centimeter. I believe you understand that, right? Now, we want to find sine theta now. That means x will give us 8 centimeter. Now let's find sine theta. Sine theta equals to opposite all over hypotenuse. So sine theta will give us, what is opposite? 8. Hypotenuse is 17. This will be our sine theta. I believe you understand that, right? You can also set question for yourself by finding cos theta. And you know that to find cos theta, that will be adjacent all over hypotenuse. That is 15 all over 17. That is cos theta. To find tan theta, TOA, opposite over adjacent, that is 8 all over 15. And I believe you understand that, right? No, so let's move forward. I'm going to solve more questions related to this. I'll be right back. Okay, class, now let's take a look at this question quickly. Find the value of x from this figure. Now, from here, you can discover that we have right angle triangle. Angle is given to us, and the hypotenuse is given to us. X is given to us. So what are we going to do? We are going to think of either we use sine or cosine, or we use tan. Let's try sine. Sine theta equals to opposite over hypotenuse. So sine 22 degree will give us opposite. Opposite is x, and the hypotenuse is 10 centimeter. So divide this by 1. We are going to have 10 centimeter multiplied by sine 22 degree equals to x. So x will give us 10 times. If you press your calculator, sine 22 degree will give us 0.3746. 0.3746. So x will give us, if we multiply all through, we are going to have 3.746. 3.746 centimeter, which we can round it up to 4 centimeter. I believe you understand that, right? So that is for that. Okay, class, now this is cosine. Cosine is a little bit different from sine. Now let's remember what we use right angle triangle. If you have something like this, right angle triangle, this is angle theta, call this A, call this B, and call this C. Now here we are not going to use sine theta equals to opposite over hypotenuse. We are going to use another thing, and you need to understand that sine theta equals to cos 90 degree minus theta. So that is telling you that sine theta equals to cos bracket 90 degree minus theta. So we are going to make use of this formula in this type of question. Now I'm going to give you a question. Look at this question. Okay class, let's solve the question. The question will give us sine 2x equals to cos bracket 90 minus 2x. So now you remember, since sine 2x equals to cos 3x, you replace sine 2x with cos 3x. This will give us cos 3x equals to cos bracket 90 minus 2x. Okay, now this cos will cancel this cos. We are left with 3x equals to 90 minus 2x. Now when this one crosses to this side, we are going to have 3x plus 2x equals to 90. So this will give us 5x equals to 90. Divide this by 5, divide this by 5. That means x will give us 18 degree. I believe you understand that, right? Now let me give you another question if you find it very difficult. Let's say for instance, I said if sine 4x equals to cos 6x, find x. Now I want to find x. What will that one be? Remember that sine theta equals to cos 90 minus theta. So this will give us sine 4x equals to cos bracket 90 minus 4x. So since sine 4x equals to cos 6x, so when you see sine 4x, you replace it with cos 6x. This will give us cos 6x equals to cos bracket 90 minus 4x, right? This cos will cancel this cos. We are left with 6x equals to 90 minus 4x. So when you bring minus 4x from this side, it turns to 6x plus 4x equals to 90 degree. So this will give us 10x equals to 90 degree. Divide this by 10, divide this by 10. This cancel this, x will give us what? 0 cancel 0, 9 degree. So that will be the value of x. I believe you understand that, right? In case you find it difficult, you can always go back to this video. Now I want to give you more questions on how to apply cosine while we are dealing with adjacent over hypotenuse.